In this series of videos, we're going to look at a method of factorising quadratic expressions called completing the square. Now, this method of completing the square is a really powerful technique because it allows us to factorise and therefore solve any quadratic equation. So that's what we're going to do in this series of videos. So the first thing I'd like you to do is just pause the video and have a go at factorising these two quadratic expressions just using the normal technique that we've learned about previously. Okay, I'm assuming you've paused the video now, so let's have a look at these. So the first thing we do when we factorise a quadratic expression is, are there two numbers that multiply together to get 9 and add together to get 6? Well, yes, the ones I can think of are 3 and 3. 3 times 3 gives us 9 and 3 plus 3 gives us 6. So we can rewrite this as x plus 3 times x plus 3, or I could just say that that is x plus 3 squared. Okay, let's have a look at this one. So two numbers that multiply together to get 1 and add together to get 2. Well, the only one that there is 1 and 1. So I can factorise this as x plus 1 times x plus 1. Or I could say that that is x plus 1 squared. Okay, and I didn't choose these expressions willy-nilly for you to have a go at. There's a reason I chose these ones. And the reason I chose these ones is because when we do factorise them, we get something that looks like this. And this here is a perfect square. So if you think about your square numbers, 1, 4, 9, 16, 25, etc. 25 is just the same thing as 5 squared. Yeah, 25 is a perfect square. This is also a perfect square because it is just something squared. And notice how it's really easy to factorise a perfect square. Okay, because the two numbers are the same. So if we can get an expression that looks like this, we can easily factorise it into what we've got here. Okay, so I'm going to write out another quadratic expression. So let's say we've got the expression x squared plus 8x plus 2. And our job is to factorise this quadratic expression. Now, if you think about the technique we used previously, are there two numbers that multiply together to get 2 and add together to get 8? Well, no, there aren't. The only ones that multiply together to get a 2 are 1 and 2, and 1 plus 2 gives us 3, not 8. So using our traditional technique that we've learned about previously, we cannot factorise this quadratic expression. So we're going to have to come up with a different technique of doing it. And what we're going to do is we're going to turn it into something that looks a bit like this, that's a perfect square, so that then we can factorise it. Okay, so first of all, I'm just going to rewrite this. So x squared plus 8x, and then I'm going to leave a space, and then I'm going to write plus 2. Okay, now if we have a look at these two expressions up here, and these two numbers are related to one another. If we half 6, that gives us 3, and then we square it, that gives us 9. Likewise, if we half 2, that gives us 1, and we square it, that also gives us 1. So in order to complete the square, we need to half the coefficient in front of x, and then square it. So if we do that, half of 8 gives us 4, 4 squared gives us 16. So we need to add 16 onto our expression, and now this bit here is a perfect square. Okay, now you might be wondering, well, sir, I can't just add 16 onto my expression. I started off with this, and now I've just suddenly added 16. I've changed the value. And you'll be right, we can't just add 16. So what do you think we need to do? Well, you're right. If we're adding 16 on here, we need to subtract 16. Okay, if we add 16 and then subtract 16, that just nets out to 0. So we haven't changed the value of our expression. So these two expressions here are equivalent. Okay, the reason why I added 16 was so that I could complete the square, and then we will be able to factorise it. So if we focus on what's in the brackets here, we can now factorise. So this factorises to x plus 4 squared. So if you don't believe me, you can just factorise that out. Find two numbers that multiply together to get 16 and add together to get 8. So 4 and 4. 4 times 4 gives me 16. 4 plus 4 gives me 8. And then we can't forget this bit here. So plus 2 minus 16, that just gives us minus 14. And we have completed the square. So we've gone from something that looks like this, that we couldn't originally factorize, into something that looks now like this, and this is called completing the square. Okay, so I'm going to do another example. So let's write down, so let's just let's do this in a different color. Let's do this in pale blue. So we've got the expression x squared plus 4x minus 3. Okay, and we need to complete the square. So I'd highly recommend you pause the video and have a go at doing it yourself. You can always look back at the example I did, but the key thing to remember is when you're completing the square is you half the coefficient in front of x and then square it. Okay, I'm assuming you've paused the video now, so let's complete the square. So we can't solve it normally because if we think about two numbers that multiply together to get negative 3 and add together to get 4, there aren't two numbers, because if we just verify that, we've got negative 3 and positive 1 and positive 1 and negative 3. That gives us negative 3, but negative 3 plus 1 is negative 2, and sorry, that should be negative 3 and plus negative 1 and plus 3, and negative 1 plus 3 is 2. So in neither of those scenarios do we get 4. So in order to factorize this, we need to complete the square. So let's rewrite this. So you've got x squared plus 4x, and now again I'm just going to leave a space so we can complete the square, and then minus 3. So in order to complete the square, I need to half the coefficient in front of x and then square it. Half of 4 gives me 2. 2 squared is 4. So I need to add on 4. Let's do it in the purple color. So I need to add on 4 in order to complete my square. But again, we can't just add on 4 willy-nilly. We've changed the value. So if we add on 4, we also need to subtract 4. Okay, now we can factorize this. So this is just x plus 2 squared. And then we've got minus 3 minus 4. That gives us minus 7. And we have completed our square. So that is our answer. Okay, I'm going to do one more just to give you a bit more practice with that. So if I scroll down a bit further. So the last one, let's say we've got x squared minus 10x minus 1. Okay, and again, pause the video, have a go at solving it yourself, or factorizing it yourself. Okay, again, I'm assuming you pause the video, so let's have a look at this. So first of all, can we always think about, before we complete the square, always think about, can we factorize it without completing the square? Are there two numbers that multiply together to get negative 1 and add together to get negative 10? Okay, always think about that first, because if there is, then we can factorize it a lot easier than if we do complete the square. But we can't, in this scenario we can't, and you probably realize that because that's the whole point of this lesson. So let's complete the square. So I'm going to rewrite this as x squared minus 10x, and now I'm going to leave a space, and then I'm going to write minus 1. So in order to complete the square, I need to half the coefficient in front of x, and then square it. So half of negative 10 is negative 5. Negative 5 squared gives us positive 25. And really, it doesn't matter if this is negative or positive, because whenever we square it, we'll always get a positive number. So this number will always be positive. So if I add 25, I need to subtract 25 as well to keep the value the same. And now I can factorize. So this becomes x minus 5 squared. And so that is that part there. And then I need to subtract 1 minus another 25. That gives us minus 26. And I have completed my square. So that is my final answer. Okay, so just to recap, whenever we complete the square, we need to half the coefficient in front of x and then square it. Okay, so I'm going to do another lesson on completing the square, doing a few more examples. But for now, I'm going to leave it there. So well done if you did get those. So keep practicing, and I hope you enjoyed that video.